Alright, Chip Disher here again. Today I'm going to be talking about kind of a follow-up to my previous post about how software developers actually get coding done and do that aspect of the work, to talk about more about what the job turns into with experience and once teams get larger. And this is really all about identifying patterns and then designing systems. So first thing to realize is this is not nearly as technical as the past talk. Really, as much as this sounds complicated because, well, or you expect it to be complicated because it's a big computer system, realistically, this is about doing things that humans already know how to do, organizing things, understanding your surroundings and stuff like that, just in a new environment. So first thing, too, to realize is large systems aren't new. We've done this for ages with mechanical systems like cars, airplanes, space shuttles, things like that, where you need to know how to put together a large component that's very complicated based on simpler kind of sub-constructs that we use. Also, we know how to do this with other sort of less concrete things like political or social arrangements, where it's about kind of doing the same thing, being able to put together pieces, but the pieces are people, and understanding how to complement them, their strengths and weaknesses, so they make a greater team. And even further into more abstract concepts, even the abilities that we have to organize money in the financial system and how investments move around and how they build a functioning society. These are things we already know how to do. And also, patterns aren't new. This is something that goes all the way back to even before humans evolved, to our ancestors, where being able to understand things like the seasons and the migration patterns of animals you're hunting were essential for your survival. And further, how you understand behavior in patterns of behavior in either yourself or your peers and colleagues, and how that allows you to understand how to interact in those environments and best kind of better yourself within them. And also, even on a more primal level, there's basic things like music and dance. If you ever find yourself kind of tapping your foot or nodding your head to a beat, it's because your brain can't help but pattern match for you, and you're noticing that all the time. So first thing is talking about how we find patterns. Well, really, this is what your brain does best. In fact, it's possibly the only thing your brain does. Is all it's trying to do is make sense of a massive amount of sensory input. So trying to find patterns so that, some picture that's coming in through your eyes and being assembled that way, you realize that's one of your friend's faces or something like that. So this isn't strange. It's not much of a stretch to realize that you'd be able to do this with other things too. So first of all, there's understanding patterns in data. An example would be when you're looking at, if you're writing a program to understand how to play back a music file or something like that. Well, the data itself actually has a pattern to it, and how you kind of go over it and put it together and apply an algorithm to that data is something that's just a pattern that you need to understand about the environment. Also, there's patterns in abstract logic itself. So things like understanding how to take one algorithm you use to solve a certain problem in one environment and apply that to a new environment, because you understand that really you're on a conceptual level you're doing the same thing, and just being able to generalize how you approach different problems into one kind of common pattern solution is really what a lot of experienced software developers spend a lot of time doing. This leads to what we call design patterns, which is basically just a way of trying to figure out how to, you can design software and algorithms that solve certain problems, but really there's patterns within how to organize those designs. So we know that, well, in certain environments, you know that you're supposed to apply certain kinds of problem solving to it. And people are developing new ways of understanding design, their own set of design patterns all the time as they go through writing software and getting more experience. And really, the reason for this is that reusability is key. They need to be able to find a way of taking knowledge and tools that they've already written in the past, already come to understand, and bring them with them as they move forward. It's how an experienced software developer becomes an effective software developer. And it's why, over time, people get better at what they're doing in this task. It's because they get better at understanding the patterns in the environment. So the next thing is building big. So this is talking about how large systems are organized, which is something that becomes important when you start looking at how you put large teams together, how developers work together. It's some of those things that when you're just getting started in the industry, you might think it's about being really clever and being able to think about a lot of things at once. Realistically, it's not. It's about being able to work well within people, being able to put together an effective team and break down a large problem into smaller components so that they can be worked on by a large group of people. So first of all, the main thing is to think in abstractions. And what this means is each large system is made up of several small problems, little sub-problems or micro-problems that are all just to address specific areas of the problem that you're trying to actually solve at the end. You're writing a word processor. One problem is how to handle the user interaction. One problem is how to actually save the file out to disk or to a network. These are abstractions. When you're thinking about the software as a whole, you don't have to think about how those work. You just know, yeah, there's a component that does that, and there's a component that does this, and here's how we'll connect them. So that's one of the things that's important. It also allows you to solve one problem at a time. This is important, first of all, just in being able to kind of address the issue and keep the problem in your mind, because as systems get big, you just can't keep track of it all. There's too many moving parts. Also, it allows you to split the task up. If you can solve one problem at a time, it means you can get a whole team of people to solve each of those problems individually, one at a time, thus doing it in parallel and doing it faster. So being able to do this effectively means you can't assume much about the system. A sub-problem is told that, okay, this is how you have to interact. So if you, in the word processor example, you want to go save a file, well, you can't assume that you can throw up a panel to ask the user for extra information. Like, oh, are you sure you wanted me to do it this way? It's like, no. When you're told how to solve the sub-problem, or when you design with your team how to solve that, they'll say, this is the way we're going to get the information, and we'll send it to you. You just operate on the data and output it in the way we want you to. And that's how you build something that's reusable, but also something that can interact within a large system. Because if everyone's trying to reach everywhere at once, you're going to make something that's just a mess. Also, it won't be maintainable. So the other thing that's kind of along the same lines as this is don't be adding requirements. Don't assume that, well, okay, I need to be able to reach out and get this piece of data. Or if I'm told that, okay, save this information that's in the document to some piece of memory and we're going to do something with it. You can't assume that, oh, well, I require that piece of memory is actually going out to a hard drive. Because what if in the future they say, no, but we want to put it in the network somewhere. We want to put it in the cloud. Then, well, now you just made something that can't be adapted to that environment. You need a very generic, adaptable tool. So it's all about simplifying the problem and trying to generalize how to look at the problem itself. This allows you to apply it in many, many environments. It allows a lot of reuse, which is really important because you don't want to write it over and over again, and also you don't want to test it over and over again. You want to be able to have one small thing which does what it needs to do very effectively and can be tested very, very well and very reliably and consumed by lots of different parts, lots of different products, lots of different parts of the product, so it becomes solid and reliable. And that's what people like. So again, it all comes down to reusability. How to actually think about how to take one small component and apply it to many different large projects. This is how you know that you've designed a very good small component of something bigger, because you don't care what the bigger thing is anymore, which means it could be anything, which means it will be everything. So that's how you make the software that really goes places. So I hope that helped explain kind of more about what a more experienced intermediate level to senior level developer would be spending their time thinking about, and what their job actually consists of, and why they get good at their job over time, and how they're effective within teams and putting teams together to solve problems. So as before, send me an email if there's any questions or comments need for a follow-up, or just something else entirely, and I'll get back to you. Anyway, thanks. Bye.